First, today let us understand the work energy story. And like I told you, work done is equal to negative of change in potential energy. Why that comes up, right? Okay. So simply I'll give you, so let us say work and potential energy theorem, because we are not uh, using the kinetic energy. Work and potential energy theorem. So simply this is a block. Yesterday I was giving you a marker example. Day before yesterday. So marker example placed on the hand. Similarly, I am giving a block example placed on a horizontal surface. Now, from this, let me take this block to a altitude of h, and how I am taking it is basically very slowly. Okay.
Yes,
Just like the charge that we've discussed, very slowly I am bringing it to distance r. Here also I am taking this block very slowly. Why I am taking it very slowly is so that kinetic energy is negligible, and also kinetic energy, change in kinetic energy is zero.
Yes.
We can take it with any kinetic energy. Change in kinetic energy will be anyway zero, but we are also adding very slowly so that we can understand, we can have kinetic energy in itself also negligible, so that we don't have any more doubts. That means kinetic energy is not there in our story at all. Very slowly has two things: negligible kinetic energy, also no change in kinetic energy. So not bothered about kinetic energy. But in this story, instead of talking about the journey while going up, I want to talk about the journey while coming down. That means now very slowly, if I will bring it back. Okay.
That is spontaneous. You can't do anything.
Coming down is a spontaneous activity. Correct?
Yes, sir.
But coming down with a constant speed, with a very slow speed,
That is impossible. We can't. We are not. We can't control it with machines.
The reason why it is coming down is what? Gravitational force, right?
Yes, sir.
But if I want to bring it down very slowly and constant speed, that means I'll have to apply a force in the upward direction, which is equal to the gravitational force in magnitude.
Then it won't come down.
Then it won't come down, but if it has a small kinetic energy in the downward direction, then it will be continuously come down. See what happens when we do the forces are equal. Net force is zero.
Yes, sir.
What happens when the net force is zero? The net acceleration is zero. Correct?
Yes, sir.
Well, what happens when net acceleration is zero? I will have a constant speed. So suppose I am making sure that the block comes down very slowly. What is there in my hands? FA is there in my hand. mg is anyways constant.
Yes.
The force FA that I am applying in the upward direction is constant. So practically, if you want to see, initially I will apply less force compared to mg. let it reach some 10 to the power minus 6 meters per second, 1 micrometer per second, and then I will make Fa is equal to mg. But to make it 1 micrometer per second or 1 nanometer per second speed, I will require dt time initially.
Yes, sir.
And that too, I am not giving zero force, I am giving Fa as just less than mg. And as soon as it attains 1 nanometer per second in the downward direction, then I will make Fa is equal to mg, so that my acceleration is zero, and that 1 nanometer per second speed remains constant.
Yes, sir.
While going up also, the story is the same. The block never goes up by itself, right?
Yes, sir.
I'll have to apply a force Fa that is just slightly more than mg for a small time dt,
Yes, sir.
so that it will attain some kind of a speed, 1 nanometer per second, 1 picometer per second. Anything is fine with me, because I am only interested in very slowly constant speed.
Yes, sir.
So as soon as it attains some small amount of speed, now I will make Fa is equal to mg. Why? Because I want my acceleration to be zero, therefore the velocity will remain constant.
Yes, sir.
Are you getting my point?
Yes.
So it is attainable. Very slowly and constant speed are attainable, not an issue.
Yes, sir.
Okay. And I am interested right now. First, I want to discuss about the journey while coming down.
Yes, sir.
Then we will come back to the journey while going up. So in the journey while coming down, so what is the reason why it is coming down?
Because it has energy store.
Because it has potential energy stored.
Why does it want to lose, sir?
But why does it want to
Lose it?
lose? Good question. We have a Amir Garib story for that, which we will come to in some time probably. But first, why is the block coming down?
Gravity.
But gravity is cancelled by my action force.
Yes.
If I will drop the block, if I will leave the block, then gravity is doing its thing, right?
Yes, sir.
Completely it is dependent on gravity. The actual reason here is why it is coming down is because it has a constant speed in the downward direction. That's why it is coming down.
What happens if constant?
I mean, I am trying to say that it is coming down because of a speed.
Okay.
Because gravitational force is cancelled by my action force.
Yes, sir.
My action force is cancelling the gravitational force. If you make my speed zero and keep Fa is equal to mg, then the block will remain at the same position.
Yes, sir.
Is this clear?
Yes, sir.
If we make speed zero and keep forces Fa is equal to mg, the forces will cancel. Acceleration is zero, constant speed, but the speed is zero, therefore it will never move. Then it is not coming down only in the first place.
It's stable.
But then I will ask you, why is the block coming down? You will say, sir, it is not coming down. Then I will ask you, then why is the block not coming down? Then you will say, it is not going down, therefore it is not going down.
Yes, sir.
Then I will say, no, gravity should be taking it down. Then what is gravity doing? Is it sleeping? Yes, it is sleeping because action force is cancelling. Is this clear?
Yes.
So, there's no problem in the answer that you gave that gravitational potential energy is taking the block downwards. The only problem that I have is that without knowing the true meaning of it, just because we heard it somewhere in some class, we are saying it because of a habit, not because of real intuitive nature thought process. I'll give multiple examples for that. Okay. So the real reason why this block in this particular story is coming down, because it has some speed in the downward direction. And because FA is in our hands, giving that speed is easy for us. Okay.
Yes.
Just apply FA just less than mg initially for some time dt, and as soon as it attains a speed, immediately make FA is equal to mg. So it is attainable. This entire story is attainable. This is doable. Right? Now, while coming down, the block is actually coming down because it has some kind of a kinetic energy.
Yes, sir, but it's negligible.
It is negligible, but the motion is occurring because of speed or velocity, and that is basically representing kinetic energy part of it.
Yes, sir.
But while this is happening, so what is the reason it is happening? Reason it is happening is towards motion, kinetic energy, speed, velocity, and all those things. Okay.
Yes, sir.
But while this is happening, what is happening to the gravitational potential energy? So simply here I am not taking any calculus. We just took height as h, gravitational force as mg, constants. So simply in our school we wrote work done by gravitational force is equal to force vector dot product with displacement vector, correct?
Yes, sir.
Let us give this fellow vector upwards as j cap, right?
Yes, sir.
So in this case, my gravitational force will be mg minus j cap, correct?
Yes, sir.
Dot product with my displacement vector while going down. Okay, this is while going down.
Considering for only gravity, that's why we're not taking applied force.
What?
We are considering only for gravity, that's why we're not taking applied force.
Yes, we are finding the work done due to gravitational force. That's why we are not considering the upward force, correct? So displacement, what is displacement while coming downwards?
H.
Minus h, or let us say h times minus j cap, right?
Yes.
So minus into minus is plus, and j dot j is 1. So will this be minus mgh or plus mgh?
Plus mgh.
Plus mgh. So using our school definition, work done by gravitational force, I got it as mgh. Now same using the same school definition, what is the work done by my action force? Work done by my action force is Fa bar dot ds bar, correct?
Yes, sir.
Fa is my mg, but in the upward direction, j cap dot, while going downwards, my displacement is h times minus j cap, correct?
Yes, sir.
So this comes out to be minus mgh.
Yes, sir.
Okay.
But then, while it's going down, we are actually making the force act upward, right?
Action force is upwards, yes. Fa is upwards.
So that doesn't matter with direction.
Whose direction? Motion of the object. Direction of what?
Vector.
Which vector?
It will depend only if the force is more or less.
The what? Repeat the statement.
So like the displacement in the positive or negative, it will depend only if the force applied is more.
Displacement vector is dependent on the motion of the object.
Yes.
The motion of the object is related to the velocity of the object.
Yes.
The idea is velocity is rate of change of displacement, because the definition is there, because energy changes are happening all the time.
Yes, sir.
Energy changes are happening all the time. Okay?
Yes, sir.
But is it going upwards or is it going downwards is completely dependent on the velocity vector. The velocity vector while coming down is in the downward direction, therefore the block is coming down. The velocity vector while going up is in the upward direction, therefore the block is going upwards.
Yes, sir.
So that's why just now, 5-10 minutes back, I told you that in a natural way, if you analyze and then figure it out, you will laugh at this particular thing. I am eventually coming there only. Why it is coming down? For velocity vector. Velocity vector, which energy is it related to? Kinetic energy.
Yes, sir.
So why it is coming down has nothing to do with my potential energy in this story.
Yes.
Right? In this particular entire story, while going up, while coming down, the reason for the motion is the velocity, and that velocity is related to kinetic energy.
Yes, sir.
Be it upwards or be it downwards, it doesn't matter. The reason for motion is velocity vector. The velocity vector has something to do with kinetic energy. Correct?
Yes, sir.
But we are keeping it constant so that we can focus on our potential energy. And to study the potential energy, first I am starting off by studying work done.
Yes.
But the reason it is coming down is kinetic energy. Then what is this work done story?
Work done is also changing.
Good. So first basis that we are right now creating for all chapters is work done is simply change in energy. Simply. Yeah.
Only change in kinetic energy.
But there is no change in kinetic energy.
Third, we used to take summation of all the forces acting is change in sorry. I mean work done of all the forces acting equal to change in kinetic energy.
That is the problem. Don't try to remember things like that. What did I just say? The simple conclusion that I am making in all of this story is work done is nothing but change in energy. It can be kinetic energy, potential energy, nuclear energy, I don't know, any energy. You use whatever energy you want. If there is changes in energy, then there is a work done.
Yes.
In thermodynamics, change in heat energy,
Yes.
or the physical output energy is what we used to call the work done in that, if you remember. But according to first law of thermodynamics, we have work done is nothing but change in heat energy and change in internal energy.
Yes.
Ultimately, I don't know these many chapters. I just know one thing: whenever there is change in energy, there is work done.
Yes.
And from my school definition, I am deriving what is the work done by the gravitational force while coming downward is mgh. What is the work done by the action force while coming downwards? Minus mgh. Is this clear?
Yes.
Now, let us say this position is A and this position is B. Okay.
Yes, sir.
Somehow, from some knowledge, I know that the gravitational potential energy that I have at A is mgh, and the gravitational potential energy at B is 0. If I take this as the reference frame, right?
Yes, sir.
See, for all potential energies, we need reference frame. So for gravity, and reference frame is always we can choose it. It's our wish.
Yes,
Okay.
sir.
So here I am taking this as my reference frame, this line as my reference frame, and so therefore I'll take this UB as 0. Automatically UA is mg. Correct?
Yes, sir.
Now, if you look at it, this fellow will become UA minus UB.
Yes, sir.
Whereas this fellow will become UB minus UA.
Sir, what is negative work done?
What is negative work done? Wait, that's what we are trying to understand.
Yes, sir.
That's exactly what we are trying to understand. Okay, I can get mgh from UA minus UB, right?
Yes, sir.
I can get minus mgh by doing UB minus UA.
Yes.
And what is this U? This is gravitational potential energy. U is representing the gravitational potential energy. Correct?
Yes, sir.
I'll just give a recap over here. Once again, try and understand the entire story. Some block is there, it was on the ground. Very slowly I took it upwards, but I am not interested in discussing upward journey. First I am interested in discussing the downward journey. So in the downward journey, what am I saying? Very slowly I am bringing the block downwards. Then we focused on why is the block coming down? Gravity. But gravity is cancelled by Fa. So the actual reason why there is a motion occurring is because of velocity vector, which
Yes,
has
sir.
something to do with the kinetic energy of the body.
Yes, sir.
What is the story about the potential energies? In this particular story, I can identify that the motion is occurring due to kinetic energy part of the story, but potential energies are still varying just for fun. Nobody knows why. The potential energy, how they are varying, to understand that, first I wanted to focus on work done by gravitational force, work done by my action force. From my school definition, work done by gravitational force, F bar dot ds bar, I got it mgh while coming downwards.
Yes, sir.
And work done by the action force is minus mgh while coming downwards.
Yes, sir.
Now, because we have something like gravitational potential energy, I am defining the reference gravitational potential energy at B as 0. Automatically at A will become plus mgh. Correct? Now, knowing U is my gravitational potential energy and knowing my W, work done, work done, work done, work done, work done, I want to write work done in terms of UA and UB.
Yes, sir.
Therefore, work done by gravitational force, I can write it as UA minus UB, and work done by my action force, I can write it as UB minus UA. Correct?
Yes, sir.
Is this clear till here?
Yes, sir.
While coming downwards, A is my initial point, right? Initial stage, and B is my final stage while coming downwards, correct?
Yes, sir.
So simply if I write it like that, my work done by gravitational force work done by the gravitational force, I got it as UA minus UB, that is initial gravitational potential energy minus final gravitational potential energy. Right?
Yes, sir.
Fine.
Yes, sir.
Whereas my work done by my action force is equal to UB minus UA, that is final potential energy minus the initial potential energy. Is this clear?
Yes, sir.
Fine.
Yes, sir.
Try and understand, in physics always change is final minus initial.
Third, how can we be final should be initial? You're taking from that point to the height.
While journey is downwards. A
Yes,
is
sir.
initial, B is final while coming downwards.
Yes, sir.
Okay.
Yes, sir.
So work done by gravitational force, I got it as UA minus UB.
Yes, sir.
A is initial, B is final, so UY minus UF. Okay.
Yes, sir.
UF minus UY.
Yes, sir.
U is what? Gravitational potential energy.
Yes, sir.
Now, the final gravitational potential energy minus initial gravitational potential energy. In physics, usually change is final minus initial.
Yes, sir.
Therefore, if I will write this as change and U is nothing but my gravitational potential energy, right?
Yes, sir.
So this will automatically become plus change in gravitational potential energy.
Yes.
Is this clear?
Then why is it plus?
UF minus UI is change in gravitational potential energy.
It's minus mgh.
I am only saying, suppose I have final heat energy minus initial heat energy. I will write this as change in heat energy.
Yes, sir.
In physics, change is written as final minus initial.
Yes, sir.
So basically, while writing this, I have nothing to do with what MGH is or anything.
Okay, so like you're writing a general statement.
A general statement I am making.
Yes, sir.
Similarly, in the above one,
It will
this
be minus delta.
gravitational potential.
Yes, sir.
Now, if you see, understand this very carefully. When we are writing UA as MGH and UB as 0, let us study what is the direction of force. Direction of force is downwards, mg,
Yes, sir.
right?
Yes, sir.
My gravitational force is downward, so my gravitational potential energy at A is mgh
Yes, sir.
and at B is 0.
Yes, sir.
My action force is upwards.
Yes, sir.
Look at this movie in a reverse way, 180 degree. The only thing that will change, see, anyways, we are going upward, we are also coming downward. So motion is not an issue if you rotate it by 180 degree. And anyways, magnitude of FA and MG are also same. So actually, the force that is acting has also nothing to do. It's just language. One I am calling it as action force, other I am calling.
MG can't become ulta.
No, MG can't become ulta. We can become ulta.
Okay.
We are not doing MG ulta. We are rotating ourselves 180 degree.
Yes, sir.
In that particular story, I will still have FA downward, MG upward, but FA is equal to MG. So suppose this is 10 Newton, that is also 10 Newton. So in this case, if you look at it practically, 10 Newton rotated by 180 degree, 10 Newton, 10 Newton. Are you getting my point?
Yes, sir.
Now, the values are all same. What are we trying to figure out then? We're trying to figure out the language part of it. Mg is downward. I said reference potential, gravitational potential energy is 0 here, and gravitational potential energy at A is mgh. But if I rotate it 180 degree, blah 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 blah, and if you look at it actually, the reference potential, energy of the action force, I will write it as U dash. U is gravitational potential energy. What is U dash? U dash is action force potential energy. Are you getting my point?
Sir, but all the things will be same only.
10 Newton, 10 Newton, 100 joule, 100 joule. All the numbers are the same. Correct?
Okay, we are changing the reference point.
We don't know what we are doing. We are just looking at something. We are just looking at some new physical quantity that we are calling it as the potential energy related to the action force.
Yes, sir.
Action potential energy. That fellow anyways has the same magnitude. That fellow's energy will have same magnitudes, mgh, everywhere.
Yes.
We are only trying to understand the story language.
Yes, sir.
So if U dash is the action potential energy, and what I am trying to say, just analyze it that way, look at it that way. See, when mg is downward 0 mgh, rotate it, then 0 mgh will become for FA, right? U dash will be 0 mgh.
Yes, sir.
The mg is like this, 0 mgh. FA is like that, 0 mgh for FA.
Yes. Yes.
Are you trying to understand this?
Yes, sir.
In terms of U dash A, if I talk, if I take U dash A as 0, automatically U dash B becomes my mgh.
Yes, sir.
So if I want to talk in those terms, the same, what is this work done gravitational force is mgh, right?
Yes, sir.
Now to get mgh, I have to do ub dash minus ua dash.
Yes, sir.
ub dash minus ua dash.
It will be positive.
B is final, A is initial.
Yes.
That means this is U dash final minus U dash initial. Correct?
Yes.
Final minus initial is my change in physics. Basically, I am writing this as delta U dash.
Yes, sir.
And this delta U dash is positive.
Yes, sir.
Let us finish this part of the story first. So here I want to get what work done by the action force is minus mgh. To get minus, I have to write it as UA dash minus UB dash, correct?
Yes, sir.
So I will write UA dash minus UB dash but A is initial, B is final. So initial dash minus final dash, which is minus delta U dash.
Yes, sir.
What I am trying to highlight here is this simply. Work done by gravitational force is negative of change in gravitational force, but also can be written as positive of the action potential energy.
Yes,
Understood?
sir.
Work
Yes.
done by gravitational force is negative of change in gravitational potential energy, but can also be written as positive of action potential energy.
Yes, sir.
Similarly, work done by action force is negative of action potential energy, but can also be written as positive of gravitational potential.
Yes, sir. So there
So,
are some difference on the perspectives, like on what basis we consider.
on what basis we consider? If I want to talk only in terms of gravity, work done by gravity is negative of change in potential of gravity. Therefore, in physics, last year you have seen W is equal to minus delta U.
Yes, sir.
But that U should be representing the same force of what you're talking of W.
Yes, sir.
WA is equal to minus delta U dash.
Yes, sir.
WG is equal to minus delta U gravitation.
But why are we considering initial minus final case of
Why are we considering initial minus final? This case.
no for work done by gravity? We tell minus mgh. Why can't we tell it's final minus initial and with positive mgh?
See, this is called corrosion. This much amount of corrosion is already damaged in your brain cells. Right? We wrote it as ui minus uf because it is ua minus ub
Yes, sir.
because it is mgh
Yes, sir.
because this minus this will give me plus mgh. So ua
Yes,
minus ub. A is initial, B is final.
yes, sir.
So in place of A I have I, in place of B I have F. Now you are
Yes,
saying why are we doing like this? Let us reverse.
I got it, sir.
So the entire format through which we have come here is keeping every small thing into account. I will revise the entire thing, but the final thing, that important thing that I want you to remember forever is that work done is always due to a force in mechanics, right?
Yes, sir.
Work done by a force is equal to negative of change in potential energy. Potential energy also is there for every force. Wherever there is force, there is potential energy.
Yes, sir.
So only if I talk of potential energy representing that force, then there is a minus.
Yes, sir.
Getting my point?
Yes, sir.
It is also obvious. It is also obvious how gravitational. So let us say Fa is not there and all those, and nothing is there. Only mg is there and mgh is there and 0 is there. Okay.
Yes, sir.
So gravitational force is acting downward. If I leave the block will fall down. How much did it lose the gravitational potential energy? mgh.
Yes, sir.
That means the change in gravitational potential energy minus mgh.
Yes, sir.
Are you getting my point?
Yes, sir.
If you let a particular force do its own work, it will always reduce its own potential energy.
Hmm.
So, did you take your wristwatch along with you?
Did I take?
Did you carry your wristwatch along with you?
Oh, it's beside what happened, sir.
No, I am just asking. So,
Yes, sir. I have.
suppose you want to have a Rolex watch.
Yes, sir.
That will only happen when God suddenly will give you, let's say, some 10 lakhs of rupees.
Yes, sir.
You asked God, why did you do this? God said, to learn physics. So, suppose God gave you 10 lakhs of rupees. I'll purchase a Rolex watch for 5 lakhs of rupees. Are you getting my point?
Yes, sir.
But suppose God gave me 100 rupees. I will go and buy a watch of 50 rupees. Whenever there is gravitational potential energy, the force will only try to reduce the gravitational potential energy.
Yes, sir.
Gravitational force, so my emotional force will always try to reduce the amount of money that I have. If I have 100 rupees, I'll spend 50 rupees. If I have 10 lakh rupees, I'll spend 5 lakh rupees.
Sir, how can you connect that with this?
That's why it's called nature. What is gravitational force doing? It is only reducing its own gravitational potential energy. Gravitational force will reduce the gravitational potential energy. Similarly, action force will reduce the action potential energy. That means pum pum force will reduce the pum pum potential energy. Any kind of a force will always try to reduce its own respective potential energy.
We can tell that it is because it wants that instability.
That's because when I have 100 rupees, I'll spend 50 rupees. Why is that? Only God knows. I will tell you the reverse of it. Let us look at it this way. Okay, there are many ways to look at it. So our question is, why does what is the statement? Gravitational force will reduce the gravitational potential energy. Correct?
Yes, sir.
Then why gravitational force is not increasing the gravitational potential energy is the question. Let us look at it in a reverse way.
Yes, sir.
The gravitational potential energy is decreasing the gravitational force is decreasing the gravitational potential energy.
Yes, sir.
That means gravitational force is not increasing the gravitational potential energy.
Yes, sir.
I am on, let's say, outside my society. I am on the main road. I am walking and I have 100 rupees. And I saw Pani Puri fell. So then I said, wait, I will make and give you Golgappa. You eat, pay me. That fellow will beat me.
Yes, sir.
He will say, you have 100 rupees. I am the person serving. So the natural order is, I give you, you eat. But I'll say, no, I am learning my potential energy story. I will serve you, you eat, give me money. Then he will say, why don't you have your own stall then?
Yes, sir.
That is a laborious work. So I gave 20 rupees, ate Pani Puri, came back. He has Pani Puri, he will feed me, I will pay him. I have paisa, I will give him. He has Pani Puri, he will give me.
Yes, sir.
So it's like go to a temple, find a nice beggar, निकाल मेरा 50 crore रुपए. He'll be like, hey me, I don't have, from where will I give? But suppose if you look at Ambani or look at newspapers, oh, just spend 50 crores just like that. He has it, so he spends it. This fellow has gravitational potential and he's spending it. The natural order of the force is to reduce its own potential energy.
Yes, sir.
When it is reducing its potential energy, let's say from 10 if we go to 0, when we talk in terms of change, final minus initial, 0 minus 10 will be minus 10, negative. Therefore, Whenever there is a force, it will try to reduce its own respective potential energy. And when you talk of in terms of change, it will always be negative of its own change in potential.
Yes, sir.
Work done by any force will be negative of its own potential energy in terms of that force. But work done by gravitational force can also be written as positive of change in action potential.
Yes, sir.
Work done by action force can also be written as positive of change in gravitational potential.
Yes, sir.
So work done by the same force is negative of change in potential energy respective force of that particular force. But suppose we have work done by some force F, we can also write it as positive of the other fellow.
Yes, sir.
Are you getting my point? Work done by action is positive of gravitation change. Work done by gravitation is positive of action change. I'll explain this fellow. I went to a temple, I have 100 rupees, I gave that fellow 5 rupees. Work done by me is change in how much amount of paisa that fellow has. The change in paisa he has is positive
Yes, sir.
because I gave him.
Yes,
And
sir.
it's natural also, right?
Yes, sir.
I am eating one dosa. The change in energy that I have gained is positive one dosa.
Yes, sir.
And I have eaten it, right?
Hmm.
Work done by action force is going to increase the gravitational potential.
Yes, sir.
Is this clear?
Yes, sir.
I'll explain the Amir Garib story later. There is a story for it. The example that I'm giving and all, there's a story that I usually explain that I'll explain later. But first, take this down with understanding of each and every detail. Motion is occurring because of velocity.
Yes, sir.
That means it has something to do with kinetic energy, nothing to do with my potential energy. But in my story, my change in kinetic energy is 0. And I'm trying to study the change in energies and work. Work and change in energy, I want to get relation. So in this entire story, while going downward, first I am studying what is the work done by gravitational force or what is work done by action force using my school definition.
Yes, sir.
From there I got something mgh minus mgh and all those stories. Now I assigned what is my gravity, assigned this position as A, this position as B. Then UA will become my gravitational potential energy at A, UB will become my gravitational potential at B. Similarly, U dash A will become action potential energy at A, U dash B will become action potential energy at A. Right?
Yes, sir.
To match this MGH story, I just have to write it in terms of UA minus UB or UB minus UA.
Yes, sir.
From there, I got UA minus UB and this minus MGH as UB minus UA. But while coming downward, I know what is initial, what is final. So now I want to write it in terms of initial and final. And
Yes.
whenever we talk in physics, final minus initial is change.
Yes, sir.
So when I talk in terms of change in gravitational potential energy, I'll get this as negative, whereas this I'll get it as positive.
Yes, sir.
But again, if I extend it and talk in terms of action potential energy, this I will get it as positive and this I'll get it as negative. So the whole story is that I can always write work done as change in potential energy, positive or negative. Now it depends on whose potential energy are you talking.
Yes, sir.
The entire complete theme of this entire story is what? Work done can be written as change in potential energy, positive or negative. I will
Yes.
write it as negative when I'm talking of the same force potential energy. I can write it as positive if I'm talking in terms of other force potential energy. So work done by gravity is negative of change in gravitational potential energy, but simultaneously positive of action potential. Whereas work done by action force is positive of gravitational potential energy, whereas it is negative of action potential.
Yes, sir.
Ultimately, this is what we have derived right now. Is it clear?
Yes, sir.
Xerox.
Where that force is applied.
What?
Work done. Force. F. Final thing.
This final thing, any force. Work done by a force is equal to negative of change in potential energy. Whose potential energy? That force is potential energy. Here I am saying gravitational potential energy, right?
Okay.
Or from where this word came, gravitational potential?
Yes,
Potential energy is anyway same. That gravitational came from gravity force.
yes, sir.
Similarly, if I have electrostatic, I'll have electrostatic potential energy. Similarly, if I have any action force, I'll have action force potential. You just name the force, it will have its own potential.
Yes, sir.
Here, which force is this is not important. Whatever work done by force, by whichever force it is, if we are talking in terms of potential energy representing that particular force, it should always come out as negative.
Yes, sir.
Because I can spend 50 rupees only when I have 50 rupees.
Yes, sir.
And when I spend my 50 rupees, what will I be remaining with? 0. So my final minus initial should automatically be minus 50. Is
Yes,
this
sir.
clear?
Yes.
I can only spend 50 when I have 50. When I don't have 50, let's say I have 0, I cannot spend 50.
Yes, sir.
When I cannot spend 50, then my final minus initial cannot be negative. I can't spend anything. It is just 0.
Yes, sir.
So I can't do anything. But if I ask someone, borrow, so from 0, I am increasing my potential energy.
Yes, sir.
My final minus initial will be positive, but that work done is not by me. Somebody gave it to me. Are you getting my point?
Yes, sir.
So what is it that I have done? Minus 50. Work done by me will become minus 50 because I've borrowed.
Yes, sir.
Is equal to positive of change in potential. So whatever work done by any particular force, you can put any force, will give you negative of change in the potential energy representing that force. Okay.
Yes.
And here we try to understand it in this example that it is not just a negative all the time. If the forces that it is representing is the same, then only it is negative. Otherwise, you can write it as positive also if you talk in terms of other fellows. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.